The program is available here. I think we can make out here the part A with the computer network laboratory with the subject code 18 CSL 57. Okay, the first lab program is we have to implement three nodes point to point network with duplex links between them. Okay, so we have to create a network and consisting of some nodes. Okay, here they have given three nodes and those should be connected as point to point. Okay, and with a duplex link between them, and we have to configure our network in such a way that the packet should be dropped. When the packet will drop, obviously when the traffic occurs or condition occurs, okay, in the network. So in such a way we have to uh, develop our program or our uh, implementation. Okay, network implementation, we have to implement the network in such a way that the condition should create and the packet should get drop. Okay, so that is what is required in the first program. For that purpose we are going to use a simulator. Why we are going to use a simulator is in order to demonstrate, right? We have to demonstrate it. Okay, so practically we have to demonstrate. That is why we are going to use the simulator here. Okay, network simulator, that is the version number 2. That is why NS2, network simulator 2. Okay, so let us start the program. So before starting with this program, so let me draw what I really wanted in my animation file. Okay, so how I configure my network. Okay, so let me take one small diagram here. So let me take this. So what I will do, I will take one network. Okay, so consisting of some nodes, as they have given information as three nodes. So here I am going to create totally four nodes. So I'll tell you why. So let me take this. So this is node number 0, zeroth node. One node I'll create second node. Okay, I'll give the name as 1 and I'll create one more node. So I'll name them as node number 2 and I'll take one more node, that is node number 3. So totally how many nodes I'll take? I'll take totally 4 nodes in such a way that two nodes will send a data to this particular node. Okay, I'll take this as one source node. Okay, this as one source node. This is one more source node. Okay, so these two nodes will send a data packet to node number 3 via these two, via node number 2. Okay, so this is how I'll transmit the data from source 1 and source 2 to node number 3, which I'll call it as destination. Okay, so I have used here one intermediate node, so where really the condition occurs or traffic occurs, so that packets will get dropped. Okay, that's what my intention. So in order to do this animation picture, okay, so this is that is why I used a network simulator. Now let me take the program directly and I'll explain each and every line so that it will be easy for you to understand. Okay, so let me take it now, the program. Yeah, so this will be, I don't want this right now. So I'll go to the program now. So just see to this. The program is, as I have said, so we are going to use a simulator. Okay, so here we are going to use the a TCL language. TCL means tool command language. Okay, so the language we are going to use TCL, that is tool command language. Okay, so what I'm going to use here, I'm going to use here TCL language, that is tool command language, TCL. Okay, tool command language. So it's also an object oriented uh, programming language. Okay, so it obeys objects and classes. Okay, we can access the classes by creating a number of objects. Then what I could do is, here I am going to use a set command. So why I am going to use a set command? So we know already, so in order to declare any variable in C or some other language, so it's something like this. See, I can declare a variable like integer a is equal to 10, isn't it? A is equal to 10. Now in my TCL, so it's not an declaration done in this way. We have to use the command set. Okay, set. Then here I can make it as a. So I can declare a variable a. Okay, that is done by the command set command. Okay, S is small letter, and here after I'm set, I have declared the variable a. I can use the variable only by using the symbol dollar. Okay, dollar a. Without dollar, it doesn't make any sense for a variable a. Okay, that's what the thing. So here what I should do, first I'm going to create the variable. Okay, so that is nothing but one object I'll create. Okay, by a set command ns network simulator. Okay, via this I'm going to create the object and class is simulator. Okay, so and please make a note of this, it should be a capital letter. And then after creating the ns object for my class main class simulator, what I will do, I am going to create two files. One file is animation file, one file is trace file. So one is animation file and one more file name is trace file. And please make a note of this, your program name, whatever you will give, okay, the same thing you give as animation file also and trace file also, so that you are able to remember the file name easily. Okay, so lab1.nam. Okay, nam indicates it's an animation file and lab1.tr means trace file. So what it do is, so what I'm going to do is I'm going to create two files here. Okay, in the writing mode. So how it works is, let me show. So I'm going to create two files here. One is animation file and name of that file is lab1.nam, isn't it? Lab1.nam. In the similar manner, I'm going to create one more file known as trace file, that is lab1.tr. I open like this, lab1.tr. Okay, so this will create two files. Okay, so then what happens, I open in the write mode. Now what will happen, by ns, on execution of ns command, okay, so the content will be updated or trace it into my animation file and trace it into my trace file. So how it works is, suppose I have create one node. Okay, in my tcl long in my program, if I create one node, that should be updated to my animation file, right? So that is done by this particular line, ns nam trace all. Okay, so each and every updation, okay, details will be updated to animation file, okay, via this ns, and updation to my trace file via this ns is done by name trace all and trace all. Okay, so these two lines will create animation file, and updation of animation file will be done by these particular two lines in the similar manner. So creating, okay, so the trace file, at the same time the content will be updated. Okay, the data will be traced to my trace file. Okay, so these particular lines will do that work. Then go to the procedure finish. Okay, so before going to this procedure finish, let me go to the creation of node, then I'll come back to my finish. Okay, so let us take the creation of node. How to create the node? The command for creation of node is set n0 $ns node. Okay, this is how we are going to create the node. This is the command. Okay, so now what I'll do, I'm going to create the node number 0 because of this one line command. Okay, so what happens, as soon as this line will be executed, we are going to create a node. Okay, what is a node? What is a node? Node number 0. Okay, so I'll write it here, node number 0. This is how your animation file will be updated here. Next, node number 1. Okay, as I have written in the previous diagram also, this is node number 1. Next, go to node number 2. Okay, so this command will create, okay, so that means the node 2 will be created here, that is node number 2. Like that, node number 3 will also create. So this is how my animation file will be created, updated with the particularly how many nodes, 4 nodes I have created. Then go to the next command, which is very very important, that is the link between the nodes. Okay, as I said you, we are supposed to provide a link between them. Without link, no data will be transmitted, right? So for a transmission of data, I requires a duplex link. Duplex link means data will be transmitted in both way. Okay, so from sender to receiver, receiver to sender, bidirectional. Okay, so between which node? Between node number 0 to node number 2. So I'm going to create a link now. Okay, so let me create a link between them. So this is how I'm going to create the link. Hope you are clear now. Okay, this is how it looks like this. Okay, so if you want still more bigger means what I'll do, I'll write it here. It's better. Node number 0, node number 1, node number 2, node number 3, right? So now duplex link between these two, 0 to 2, done. Okay, so and I have provided a bandwidth. Okay, so the maximum number of packets that can transmit it, so that I have provided here 200 MB. Okay, so this is the bandwidth I have set, and propagation delay between them. Okay, so this is 10 ms, that means 10 milliseconds. So the propagation delay is nothing but the time taken by a packet to transmit a data from one node to another node. Okay, so with an acknowledgement packet also, we'll give the acknowledgement packet also. So that complete time is said to be one propagation delay. So I have taken here 10 milliseconds and here drop time. Okay, so that's a propagation delay I've provided, and with a drop time I've provided an information such as if the packets, if the capacity of the link is 200 MB, if you send more packets, okay, so more than the capacity of the link, then the packet should drop. Okay, so I'll provide that information by giving a drop tail here. Okay, and here please remember D should be capital and D should be capital. Okay, so on here this line will provides me a link between 0 to node number 2. Okay, then in the similar manner I'll go to node number 1 to node number 2. Okay, let me do it. So node number 1 to node number 2, the same way I'll just attach here the link between those two, and I'm giving a bandwidth here 100 MB, and we can make out here. So this is the propagation delay, this is the bandwidth, and propagation delay is 5 milliseconds. You can give propagation delay, you can vary, you can give any value. Okay, so and here also drop tail is available, and duplex link between node number 2 to node number 3. So I have to provide the link between each and every node, otherwise no data will be transmitted, right? Without any link, no data will be transmitted. And just make out here, this is only 1 MB, here it is 200 MB. Okay, so the data from 0 to 2 capacity is 200, even 1 to 2 is 100 MB, but the capacity between 2 to 3 is only 1 MB. So what will happen? Obviously in this particular node the condition will create, right? So this is where in the node number 2, 100% probably, okay, the maximum, the uh, creation of condition occurs. So what I could say, the packets may drop at node number 2. There is a possibility, right? So the packet may drop here because of condition available there. And even Q limit also I am setting between node number 0 to node number 2 and node number 1 to node number 2. Okay, so we can give the Q limit between 0 to 2 and 1 to 2 by giving a command Q limit. Okay, then come to the very important point. It is very important, and it is the main thing, which concept, this concept is repeatedly available in each and every program. Okay, so this is very important. So what I should do, we know, we are familiar with one concept, that so each and every node is having a file layers, right? So application layer, transport layer, network layer, data link layer, and physical layer, right? So and here we are going to create the packet, right? We are going to create the packet. So I'll consider it as an application, right? The application where the packets will be created, the message will be created. Okay, so here at the same time the transport layer, right? So the transport layer consisting of protocol TCP and UDP, right? So that is that protocol will receive the packet from the application layer and send it to the network, right? So now for that purpose I'm going to use here UDP. Okay, UDP I'm going to use here. So that is what UDP. So I'm using the UDP agent here. So I'm giving the UDP 0. Okay, so I've set it, that means I've created it. Now I attach that to a node number 0. Okay, now to the node number 0 I have attached UDP 0. Okay, so let me write it here, UDP 0. Okay, in the similar manner, so this is from transport layer. Similar manner, so I'm going to create here, see from the application, so the packet should be created, right? So that is done by CBR. Okay, so that is said to be a CBR, means constant bit rate, in the sense that, so it will create the traffic in such a way that, or it will create a packet in such a way that all the packets are of same size, constant size. That's why it is constant bit rate. Okay, now I'll take it as CBR 0. I've created it using a set command, and I've just attached it to the this node number 0. Okay, so that is done by this particular command. Set it and then attach it. Okay, so then we have some other information such as set the packet size at interval. What is that? So as I said you, when the packet has been created, right, when the packet has been created, so I said some size should be given. You can give a some size. Suppose here they have provided 500, right? So if it is 500, something like 500 MB, okay, it could be something like that. So what will happen if it is 500, all 500 MB, then all the packets will be of same size, 500 MB. First packet is also 500 MB, second packet is also 500 MB, and even nth packet is also 500 MB. Okay, so that is what packet size. So please make a note of this. This is packet size underscore space 500. It is something like packet size is equal to 500 MB. Okay, is equal to. It gives you like equate symbol. Okay, so you have to give a space here. That should be very important. Otherwise, it leads to error. In the similar manner, for this, after one packet is created, at what interval of time the second packet should be created, right? So that interval between first packet to a second packet is given by set interval, that is 0.005. Okay, so this is what provided here. Now come to the UDP1. So that is nothing but, now I attached UDP0 to node number 0, CBR0 to node number 0. Okay, and now it is ready to create the packet and send the packet. Okay, next go for UDP1. So this 4 lines, right? So what I'll do, I'll create UDP1. Okay, I'll set the UDP1 and I'll attach to node number 1. Okay, very simple. So here it is UDP1, UDP1. Okay, set it and just attach it to node number 1. In the similar manner, here it is CBR1, CBR1. Okay, so here where the application which will create the packets. Now what happens here, I have not given any packet size, so you can give the packet size, okay, 500 MB or 600 MB. Okay, same as this. So these 2 lines you can repeat here. Otherwise, if you keep as it is, what will happen? By default, it will take some size. That's all. Okay. So then go to UDP2 and CBR2. Attach to node number 2. Okay. So here I have attached CBR2 to node number 2 and UDP2 to node number 2. Okay. So similarly, we'll go to node number 3. So the node number 3 will do what? So as I said you, node number 0 and node number 1 will be the source node. That means both will send a packet to the network. But node number 3, it will just receive the packet. That's all. It never send any data. So I'll call this node number 3 as sync node. Okay. So it's a destination node or sync node. So for that purpose, what I will do, I'm going to create. Okay. So here as a it's a sync or a null. Okay. So I'm giving a object name as null. Even you can give it as sync also. It's not wrong. Okay. So you can give any name. So I hope you are clear now. Okay. So we can go to this particular sync node or terminal node. Then go to the next command. So that is, see, here it is sync. Okay, I'll do one thing. I will make it as null 0 because the same name I have provided there. Okay, so let me change it. Instead of sync, I'll call it as null because the same thing I provided. So let it be null. Okay. Okay, let me write it as null. Since the name provided is null, so even here I'll call it as null. Null 0. You can give any name. It is not mandatory that you should give the null 0 only. Okay, then go to the next command. That is very important. That is connect command. So connect command will help you, or it will give you to provide source and destination connection. Okay, so from source, that means node number 0 to node number 3, I'll send the packet, isn't it? Hope you are clear, right? So we are going to send the packet from node number 0 to node number 3, right? Node number 0 to node number 3, I'll send the packet, isn't it? So something like this. Yeah, node number 0 to node number 3, I'll send the packet, right? So even here, node number 1 to node number 3. Okay, something like this. This is so, this is destination. But what will happen? Even though I've given 1 to 3, but the packet will be moved via node number 2 only, right? Because the connection between 0 to 3 is not there, but connection between 0 to 2, then 2 to 3 is there, isn't it? That is why. Okay, so this is how the packet will transmit. This is the path from this source number 1 to 2, and from source number second source to node number 2, then from 2 to 3 the packet will move. Okay, that is why the connect between UDP 0 to null 0, then UDP 1 to null 0. Okay, so this command has been provided, and by this we have done packet creation, node creation, link between the node, isn't it? So this is all right. So we have already done connection like this, 1 to 2, 2 to 3, everything we have done. Now the CBR 0 is ready to insert the packet to the network, right? So it will start at 0.1. At what time it will start? When the time is 0.1, it will start. Okay, the source will putting the packet at the time interval of 0.1 with a time of 0.1. And even the second one, that means the node number 1 will also set the packets and put it into the network at the time 0.2. Okay, so that's what we have given a command $cbr0 start. Okay, this command will gives you an information of at what time the packets source 1 will put the packet into the network. Similarly, at what time the node number 1 will put the packet into the network. Okay, so this information is available in this node. And we'll go to the last command and very important command, that is finish command. When it comes to finish command, what will happen? At what time the inserting the packet into the network should be stopped, right? So it will be stopped at time with a 1. Okay, with some scale. Okay, so 0.1 it has been started, and when it reaches to 1 it will stop. Okay, you can vary the time, you can make it as 1, you can make it as 2, you can make it as 10, anything. Then we have to finish, and when it comes to this finish, okay, let me go to the finish. Okay, so the procedure for this finish is available here. What will happen in this finish? This is a procedure in which we have created the objects for network simulator and trace file and NAM file, right? So these are all the objects. So what I'll do, I'll just flush trace all the data. Okay, so this command will send the data or update the data or dump the data to this particular animation file and trace file, right? It will update the data, dump the data to the trace file and animation file, and whatever the data is available, that will be transmitted to a secondary storage device. Okay, so in the secondary storage device we will get our files, okay, animation file and trace file. So now that particular objects, whatever we have utilized NF and TF, that may be utilized by some other purpose. We can create new we can using the same objects, you can access the class, okay, for other projects and all. This is how we are going to close the TF and close the NF. Okay. Now we will be getting the animation file in some address ampersand. We'll go there. We'll get the animation file and just execute it. Okay. We'll run that. We'll execute the animation file. Okay. So that is what it will do. Then we'll come to the command, that is $ns run. So this is where your program get run. Okay. This is the command. Without this command, program never execute. Okay. So then we'll go to the execution of this using the Ubuntu. Okay, so let me take you. Yeah, so here we have to execute the program. Okay, so it's already there in my system with my password. Just enter. Okay, So now what I'll do, I'll just open the terminal mode. Okay, so let me show you how it will work. Yeah, we should always, it will work, right? Terminal mode, right? So your Linux operating system will be, it will accept the commands, and whatever the command you will give, that will be executed, right? So that is how your Linux operating system works. So let me go to the terminal now. That is where you can give the commands. Okay. So this is the command. Now what I should do, I have to open the file. First I have to open in the editor mode where I can type the program. Okay. So the command for that is gedit program name. Okay. So here it is something. So I'll give you one example first. Suppose I'll open like this prg.tcl. So if I open this, see, I'll get the editor mode. Here I can type the program. I can type the program here. Okay. So suppose if I take a program, I will type the program here and have to save it here. Okay. Then I have to close this. It will take me back to my command mode. This is how it will work. Okay. So now what I'll do, I will go to the program. So that is already I have typed and I've kept here. So that program is lab1 dot lab1 program name is lab1. So here it is lab1.tcl. See, since the program we have written in the tool command language, the program name is also extended by .tcl. Okay, so that we should be aware of it. Okay, just enter it. So here I have already typed the program, same program. So here is available the program. Okay, so whatever the program I have explained, same thing is available here. Okay, now please remember, uh, here small mistakes, right? Some errors will be done by the students. It may be after before the opening square bracket, we have to give a space here. Okay, so probably we will do that mistake. Okay, here it won't accept. After the see, after ns you have to give a space here. Okay, or in this way you can remember how it is. Before square bracket you have to give a space, and even before flower bracket, opening of flower bracket, you have to give a space. You can make out here. See, this is where I've given a space, and even here also space. Okay, and it's a case sensitive, so capital letter, small letter, everything is a important. Okay, so it won't be acceptable. All such kind of mistakes won't be acceptable. Okay, so everything is available here, same program. And even remember, this is lab1.tcl. What I have done, even I have written here lab1.nav, lab1.tr, like that. Okay, so that I can remember easily what is my animation file name, what is my trace file name. Okay, if I give different name, it's very difficult for me to uh, remember the name, right? So just save it. And now execution, right? Execution command is very simple. Okay, so just we have to type ns program name, that is lab1.tcl. Just enter it. See, we got the animation file. Okay, so I got the animation file directly here. Since I have not done any mistakes, there is no error. If there is any error, you won't get the animation file. Okay, let me show that better here. Gedit, how the error will come. Let me show that. Okay, suppose here I have removed the space. Now what will happen? Just save it. Okay, so then I'll close this. Now we run it. Okay, ns command, let's run it. See, here we'll get an error. So obviously set ns, so there is a mistake, there's an error. It will show you very clearly what's the error also. So please see to this particular line. Okay, and analyze it, what's a mistake. So space is not available. So I'll go back to my program. See here, gedit, I'll go back to my program and just give a space here. Okay, then save it, then close this, then run it. So I got the animation file. Okay, so with some address, I have some animation file. I already told you. Now we have to execute. Now we have to run it. Okay, that is done by just play button. We have to run it. So see, it is started by 0.1 interval. Now it is ended by with a interval of 1. Okay, when it reaches to 1.0, it will stop. And just to see the relayout, you can make some relayout. Okay, so see, the packets are getting dropped from node number 2 because of condition. Okay, so this is how it will work. Now what I should do, I've run my animation file. As I told you, we will be available uh, with the animation file and trace file also, right? So this is the animation file where you got the pictured representation, right? You're getting some animation picture, so that is what your animation file lab1.nam. See here, we can make out. Then you can ask me one more question, where is our trace file? Right, trace file is also updated, right? Where it is exist. Okay, so just I'll open it in the normal way, that is gedit lab1 dot what name I have given dot tr. Just enter. Okay, so this is how my trace file looks. Okay, so this is where my trace file looks. I'll just tell you a small information regarding this, which is very very important. This is consisting of totally 12 columns. Okay, so the first column is event column. Okay, event is nothing but whether your packet is enqueued, dequeued, or it is received. That means data is received or data is dropped. Okay, so all that information is available with plus as enqueue, minus as dequeue, or as packet is received, and d as packet dropped. Okay, so let me show you where d exists. See, since packets are dropped, we have already seen in the animation file, obviously we will get a d here, right? Exactly, right? That is acceptable. So I hope you are able to see some d at the end. Why? After some time I got packets getting dropped, so at the end, right? So let me come down, just see you. Yeah, let me take full down. See you, d. This is where packet get dropped, right? So and the first column is d, as I told you, this is an event. The second is time. Okay, so interval of time, as where the time we have seen, no, so that is t. That's a second column. The third column is source, which is a source node, and fourth column is destination node. Okay, and fifth column is your packet type. So packet is created by CBR, constant bit rate. That's why CBR. And next column is packet size. That is how much size it is. So 500. You can make out here 500, which I have set by CBR 0, but there is some 210 is there, maybe by CBR 2, because I have not given any 500, right? So by default, 210 is the packet size. It has been created, and this is next column is some flags which is not available. Then go to your UDP information, that is flow information, that is 0 for UDP. And again we have a source address and destination address, these two columns. And this is packet information, sequence number and packet ID. Okay, so this is packet ID and sequence number, last two columns. Hope you are clear. Okay, so these are all columns are there. If you want, ma'am, we still we want more information, means you can see to it in the lab manual and all, we have provided that information. Okay, let me show you if you want. See you, all 12 columns, right? Event, time, from node, to node, packet type, packet size, flags, flow ID, then source address, destination address, sequence number, and packet ID. Okay, now I hope you are clear now. Okay, so now what I want is, in the question they clearly mentioned we want the number of packets dropped, right? So here I can't count all d, right? How many d's are there? I can't count with this very vast and the very big trace file. So what I will do, I'm going to write the awk file. Okay, so what my awk file will do, in that awk file, what code I'll write is, just I will fetch the data whichever I required from this trace file. What data I required? In the first column, wherever d is there. Okay, so that many d's I just want to count how many d's are there, isn't it? So for that purpose I'm going to write a command, program here, one small program I'll write it. Okay, so let me write that program, that is gedit lab1.awk. Okay, so we have to type the program. Anyway, I already typed it, so we are able to see that lab1.tr. Okay, lab1.awk. I've already typed it. Okay, so or else you have to type anyway. So this is what. So here the variable declaration I have done in the begin. That is c is equal to 0. The variable c will give you the count. How many d's are there in my first column? Okay, that is what for that purpose I have declared one variable, that is c. Now here, wherever the first column, okay, $1, is equal to, please don't give a space between these two, it's an error. Okay, so double equal to $1 is equal to D. Okay, so that is equal to D. That means it will give you an information of what packet is dropped. It is equal to D. Then what will happen? The C will be incremented, okay, by this C++. That's all. Okay, now I'll just print the output as the number of packets dropped is equal to % of D, that is equal to C. That's all. Very simple. This will give you the information of how many packets are dropped, isn't it? And here I have given some information such as fifth column and 11th column. I already told you fifth column is packet type, that is CBR, and 11th column is packet ID or sequence number, right? Okay, so that is sequence number. I think this is 11th column sequence number. So that information is also, if you want, it will display. Okay, 11th column is sequence number. Okay, so I've already typed anyway. Let me execute it by command awk -f. Okay, so I have to access the data lab1.awk, where I have written the code for that, and from which file I have to access, from lab1.tr. Okay, enter. So this is how, right? So the number of packets dropped is equal to 24. This is available. At the same time, that 24 packets, what's the type of the packet and what is the sequence number of that, that's also available here. Okay, okay, so this is our program number 1. I've